Hey guys, welcome to my video. So this is that washing machine motor I've been testing quite a bit on lately, and I was doing a couple of tests I thought you guys might be interested in. So what we're going to do is get this fired up. The input is down here. These are all 48 volt batteries down here, and then the output coming out of the motor is always white and yellow. Goes through the capacitor and then into 48 volt batteries. So we're running on 48, charging 48, and then we're going to switch it into this light bulb. And yeah, you got this. This is one of my circuits I made. It's basically three-phase, but only one polarity. And it runs it pretty nice. So what we're going to do is fire this up and see how this interacts, and then we're going to change it over to the light bulbs. So let's get this thing started up. So you can see the capacitor voltage 65 as these batteries are charging up, and the amperage right now we're just over 3. So this is the basic charging the second battery. But now what we're going to do is we're going to turn this off, and I'm going to switch this into the lights. So disconnect this and hook up these lights, but only one of them is hooked up at the moment. So this one's on, this one's off, and so we're gonna fire this up again, and you can see we're using just maybe 100 milliamps more than we did charging the batteries. These are 200 watt light bulbs. And yeah, it runs really smooth just like that. So now you can see the capacitor voltage is at 59 volts, so it's still higher than the battery bank that's sitting at about 52. But what happens is when you try to pull out output out of these circuits like this, a lot of times people will overload it. So right now it's running real stable, but watch what happens when we hook up another light bulb. Okay. Went way up, and now the capacitor is sitting at lower voltage than the battery, so 43 volts. So now you just turn this into a generator with the Lenz law having, you know, not very good effects. So if we turn this back off, see, you can hear the motor change. The capacitor voltage goes back above the battery, which is the most important part, and the amperage went back down to where it was. And we still have good usable torque from the motor. This thing's really hard to slow down, and we still get the output out even slowing it down. But as you can see, if you slow it down too much, the voltage comes down. But as long as you keep it above the battery voltage, then it won't load it up too much. So yeah, if you don't load it any more than this, it's above the battery voltage. You could still get good torque and still have the output. So here's the scope shot over here, what this is looking like. So this is at full power, so the pulse width modulator is all the way on. But yeah, that's quite a bit of energy, quite a bit of heat coming off these things. So anyway, thanks for watching.